This video is a review of the overhaul of a Shimano through axle hub using cup and cone bearings that uses the Shimano HG or HyperGlide free hub. For an explanation of the basic concepts and terminology, see our video, How Hubs Work. Front hubs share many of the same concepts as the rear and are reviewed at the end of the video. This is an area where it's useful to seek out the manufacturer's information, such as schematics and other information. These through axle hubs overhaul very similar to the 10mm threaded free hubs. We look at the part schematic and we can see that the bearings sit outboard of the free hub. These hubs, like other hubs, adjust from the non-drive side. That also means they come apart from the non-drive side. Like any hub overhaul, begin by removing the rotor and any cassette sprockets. Next, clamp the drive side in an axle vise such as the AV5 from Park Tool. Using a cone wrench, hold the lower cone. This style of lock nut requires a cone wrench as well. Turn the lock nut counterclockwise, loosen, and remove it. Next, loosen and remove the cone. Carefully lift the wheel, watching not to drop any bearings on the floor or workbench. With the hub off the axle, we can now get to the bearings. This seal is preventing this bearing retainer from removing. These seals can be easily damaged. You need to be very careful in removal. In this case, we're going to take a thin tip screwdriver, gently pry, rotate, rotate, lifting gently, gently, and it's up. Inside are the ball bearings. Comes out in a retainer. That's the non-drive side. Flip the hub. And inside are more bearings. This side, bearings are loose, not in a retainer. I'll use a magnet to remove. And remember to inspect inside in case anything has fallen inside the hub shell. One last errant ball bearing. This dust cover on this side, although it could be removed potentially because we can get inside and get them out and back in, probably best to leave this. Again, easy to damage. If you can, leave them in place. Now to clean the parts. We'll use some light solvent, a little bit, and actually a toothbrush to get inside this retainer. Just a light brush is fine. An old toothbrush, completely adequate for this job with some mild solvents. Cone surfaces and up inside this lip provides a seal. That's clean. Lock nut already clean. Dust seal, the cover should also be cleaned. The ball bearings, cleaned. The axle removed from the vise. It is cleaned as well. Cleaned. Next, the free hub. The free hub, we do not want solvent poured around the free hub. We're simply going to wipe it clean. We're going to wipe inside We could use Q-tips, end of a rag. We don't want solvent in here because there's a light oil in the free hub that lubricates the ratcheting. Solvent's going to remove that. The free hubs simply stay on the hub body for this type of axle bearing overhaul. Parts been blown dry, they're clean. Now, time to inspect. That means looking, also feeling. The ball bearings themselves look shiny. They're all bright and shiny, they're reusable. Interesting, one side was in a retainer, the drive side were loose. There are also clearly two different sizes. We have 16 bearings counted here. Pick up just one of them and measure. They're not 1/8 inch, they're 5/32. 5/32. These appear to be the next size up, 3/16. Again, they can stay in the retainer. The ball bearings trace a path along the cone. So here, I can just trace it directly, looking, and it's also handy to feel with the tip of a pick or even a ballpoint pin. This feels smooth and nice. This other cone, there's the ball path. Trace it, looking for pits and feeling for pits. This one appears to be okay. A pitted surface can look like this. It can be smooth, and then these pits appear. Once they appear, they're not going to get any better. The cone is ruined. Next, we're also going to trace the ball path in the hub. In that curved surface, we're going to look around for pitting. And again, we can trace it and feel if there's any pitting down inside where the bearings like to roll. This one feels pretty good. On this model, the axle and the drive side cone are effectively one. This has a labyrinth inside that seal, and it's useful to put a little grease in there. That's going to help keep water out from getting inside the bearing mechanism. This is now installed and secured in our vise. Next, to assemble the hub, these were the non-drive side bearings. We can apply a layer of grease to these. We can apply a layer where they sit in the cup. Good. Plenty of grease. Next is the seal, same orientation. Press evenly and then gently down, keeping it even, working it down till it's in the same orientation it was. A slight spin, I can feel it's higher on this side slightly. There, we are now down where the seal was. That's ready to be flipped. Next is the drive side. These had loose bearings. This one is a little bit trickier. Grease goes down inside the cup. We want a healthy bed of grease. Even that up. That is where the bearings are going to sit. In this model, these were the 5/32 loose bearings. Anytime we're using a loose bearing, they must sit flat in the cup, not jumbled. The bed of grease is thick, so it simply holds them in place, as well as provide lubrication for a long period of time. One more. This is a good place where some supplemental lighting is good. We can look inside. They're pretty flat, slightly jumbled right there. So let's get those flat. Cone is installed. It will simply be perfect there. All flat and ready to go. Time to put it all together again. One last bit of grease. Again, this cone has a little labyrinth. I'm going to put a little grease in there to fill that, to help keep out any water. Bearing lubrication already in the hub. The drive side came out last. It goes together first. Install. Careful not to jumble any bearings. It's on. Don't pick it up and down again. Those loose bearings could get jumbled. The cone is next. Thread this in place. Last will be the lock nut. Now the lock nut. Next up, adjustment. Bearing adjustment for an adjustable hub should be as loose as possible, but without play or knocking. The setting may or may not end up subjectively smooth and nice to your fingers. But remember, it is the wheel that's rotating with all that leverage around the axle. Your fingers don't really have that. What you're feeling subjectively is the wear and also the quality and model of the hub. On the threaded, smaller 10 and 9 millimeter hubs, the quick release setting effectively becomes part of the bearing adjustment due to the flex of the axle. These larger, oversized axles tend not to do that. Therefore, the setting outside the bike is the same as when it's mounted inside the bike. To find that loosest setting possible, we're going to actually make play in the hub by installing the cone wrench on the cone, back up a little bit with the lock nut loose. We're going to come down gently until we just feel contact of the cone hitting the ball bearings right there. We're going to make play by going 90 degrees loose, 1/4 turn, hold. We're going to run the lock nut down. Approximately 10 Newton meters. This is going to be muscle memory. Difficult to get a torque wrench on this particular nut, so that's when muscle memory and that learning from torque wrenches becomes important. With this secure, we'll check for play. Grab the axle, we grab the rim, and we rock back and forth. Most definitely play. There's knocking. That's okay. We will now slowly proceed to get rid of it step by step. Hold the cone, break free of the lock nut. Going to advance, not a 1/4 turn, maybe an 1/8 of a turn. Hold and secure. Still play, still knocking, it's getting better. Proceed with another small increment. Hold this wrench slightly clockwise, creeping along until play disappears, rocking the rim back and forth, rotating it around. There is no play. Anything looser, we had play. This is the setting that we want. As a double check, we'll remove it from the vise, grab both ends, pull up and down, alternating, turning it. Don't feel any play, feels reasonable. Anything looser was play. This is the setting that you need. If you're working without an axle vise, there are provided some wrench flats on this side that will help you control, but definitely a little bit slower this way, working with the two wrenches here, trying to control it with one over here. Front hubs, there's not as much going on. What's important to know is which side to adjust from and which side comes apart first. So here we can see this side has a wrench flat. Hard to know where the cone would be. This side, we can barely see a wrench flat in here. This is where having a look at the manufacturer part schematic can be really handy. We can see here, these adjust from and come apart from the drive side. The non-rotor side, that's going to come off. Front hub, we can secure the fixed side in the axle vise. This should be pried up with a thin-tip screwdriver. However, if we rotate this carefully and feel with the fingernail, there's one spot here that's provided a recess for the screwdriver. That's where we will fit. It pops up. It is off. The cone is held with the cone wrench for the appropriate size. The top one is a 22 millimeter in this case, but a small adjustable used carefully and closed fully does the job well. Loosen the lock nut. It's going to come off. Below is the cone. Inside the cone will be ball bearings. Without the cone, we lift the hub. Inside are the ball bearings. They come out, cleaned, greased, and assembled. Put back together, and the adjustment procedure is the same. That was an overhaul of the Shimano Thru axle cup and cone system using the HyperGlide freehub. For more repair help, see the Park Tool YouTube channel.